One. Start.
Okay, good morning, all the students. Yesterday, in the last class, we have discussed about stationary waves and principle of superimposition of waves. And also, according to this principle, two progressive waves, equal amplitude and equal frequencies, how they are combining and form. And also formation of stationary waves in stretched strings. And when a stretched string is plucked at the middle, then what happens? We can see lowest frequency, fundamental frequency is formed in the stretched string. We can see two nodal points at the ends. And again, in the second harmonic, which we call it as first overtone is formed. The three loops are formed, second harmonic are formed. What happens? And what is the equation for velocity and frequencies? And also, when the harmonics are continuously formed, then what is the ratio of their harmonics? Nu1 is to Nu2 is to Nu3, we have discussed. And also, loss of stretched string. If n loops are formed in a stretched string, what is the formula? That also we have discussed. And three laws, based on that we have already completed those. This is, now we are going to see formation of stationary waves in an open pipe. When we are talking about a open pipe, what is the medium here? The medium is air particle inside it. Open pipe means it is which both ends are open, that is called open pipe. And here antinodes are formed at the ends. The reason is the air particles are free at both the open ends, therefore no possibility of formation of nodes combining two standing any two transverse waves are formed or longitudinal waves are formed. Generally longitudinal stationary waves are formed in the gases. So in the air particles, these stationary waves are forming. Closed side, always we can see a nodal point, and open side, we can see antinodes. Here, a open pipe means both ends are open, that's why antinodes are formed. Now, when first harmonic, as we have seen in the stretched string, fundamental frequency, first overtone, second overtone, and or we call it as second harmonic or third harmonic, how we can derive the equations. Let us see. In an open pipe, two antinodes are formed on both sides. We have discussed. You see these open pipes, and here first both sides are open. So two antinodes. So this length is lambda by 2. So length is becomes 2L. Lambda is equal to 2L. And this is when fundamental frequency or first harmonic is formed. And you can see in the second diagram, again at the open side, there are two antinodes, but at the middle, we can see two nodal points, as you can see in this diagram. This is here the length. Here we can see three consecutive antinodes. Are you observing? So this length is exactly lambda. Lambda by 2 plus lambda by 2. This is lambda. And whereas in third harmonic, you can see again two loops are formed, but again at both sides you can see two antinodal points. And from this we can modes of vibration in this open pipe, how we can see the equation we can follow like this. When first harmonic is formed, lambda 1 is equal to L. Therefore, frequency, that is fundamental frequency, V by lambda 1, that is V by 2L. Again, coming to next, when second harmonic is formed, lambda by 2 plus lambda by 2, that is lambda is exactly L. Therefore, V by L, this also you can write 2V by 2L. By multiplying, and numerator should kept as a constant to L, you can multiply or you can easily remember that is V by L. While coming to third harmonic, there are 3 lambda by 2s are there, 3 lambda by 2. We are writing here lambda 3 means third harmonic to indicate that we are writing that subscript 3. So here lambda value is 2L by 3. So while substituting that, frequency is 3V by 2L. So you can easily tell the frequencies ratio, first harmonic, second harmonic, and third harmonic, how they are formed in open pipe. That is V by 2L is to V by L is to 3V by 2L, as you can see. So this ratio is 1:2:3. So you can tell the harmonics in an open pipe are in the ratio of natural numbers, 1:2:3:4, and so on. That is how harmonics are formed in open pipe. Now coming to closed pipe. Well, if you are telling about closed pipe, one side is open and it's a formation of stationary waves in closed pipe. And here we can see in case of closed pipe, one end of pipe is closed, other end is open, and it contains air column. Then you can see the images, how these are formed in case of open pipe. See, there are 3 closed pipes drawn here. Here, always in closed side nodal points and open side antinodes are formed. And this length is exactly one node and consecutive antinode distance is lambda by 4. This is lambda by 4. When this is first harmonic is heard, fundamental frequency is formed. And in the second diagram, you can see the standing wave of 2 nodal points and 1 antinode. While drawing these diagrams, students are very careful to draw this. Always open side you have to draw antinode. The length here in the terms of lambda you are writing, as there are 2 consecutive antinode points and 2 nodal points and 2 antinodes. Therefore, this is lambda by 4 plus lambda by 4 plus lambda by 4. Whenever there is antinode and node, that distance is lambda by 4. So like this, node and antinode, and node and antinode, node and antinode. There are 3 are there. Therefore, this is when first overturn is heard 3 lambda by 4. That is, length is 3 times more as the wave is concerned in terms of lambda. And here in the third diagram, you can see how many 2 nodal points, and here you can see 3 nodal points. While wave is formed in the second harmonic, 3 nodal points. Here node and node, antinode like this, you can see 5 lambda by 4. The length is 5 lambda by 4 we have to take. And let us see modes of vibration in it. First harmonic, during first harmonic, 1 node and 1 antinode are formed in closed pipe, that L is equal to lambda by 4. So V new one is V by 4L. This is called fundamental frequency. As you can see in the 2-dimensional, 3-dimensional diagram, this is, some may be having a doubt, where is the complete 2 nodal points are formed as in the plucked string. Here nodal point is closed side, and another side, where is the nodal point? Actually here in the open side antinode, but this nodal point is formed in the air itself above the open side. To show that, we are taking this 3-dimensional diagram. From this also, here you can see the frequencies. The third harmonic or first overtone, 2 nodes and 2 antinodes. So here L lambda by 3 plus lambda by 3, what we have discussed earlier, 3 lambda by 4. So nu3, third harmonic is formed 3v by 4l, like this first harmonic or second harmonic. Here 3 notes and 3 antinodes, and L, here it is 5v by 4l, like this. Nu1 is to nu2 is to nu3 and so on. Here you have to take 1 is to 3 is to 5. Here the harmonics in closed pipe are in the ratio of odd numbers. We have to remember that. Here, while taking that, odd numbers frequencies you have to take. Okay, this is about closed and open pipes. In case of closed pipe, we have taken the ratio as 1 is to 3 is to 5. If it is open pipe, 1 is to 3 is to 3 and so on. You have to remember that. And another topic is beats. What are these beats? In this chapter, we are going to see what are beats. When two sounds are slightly different frequencies. Here we have discussed about transverse longitudinal waves or transverse wave. When there are two waves slightly different in their frequencies traveling in same direction along the same line of action, the intensity of resulting sound is waxing and waning. This phenomena is called beats. Generally, beats are formed due to change in its frequency. Two sound waves at a time produced, but due to the change in its frequency, we can hear sounds. Those are called beats. Generally, it is used in musical instruments. Number of beats per second, or we call it as number of beat frequency. We are also known as, this is also beat frequency. That beat frequency is the difference of nu1 minus nu2 or nu2 minus nu1 also you can read. Whatever larger one you can take first. Nu1 difference, nu2. The frequency is difference. For example, 256 and 252. 256 hertz one tuning fork and 252 hertz another tuning fork. When these two tuning forks are at a time vibrated, you can hear 4 beats. 256 minus 252, the difference is 4 hertz. So number of beats per hertz are only 4. The difference of the frequencies are repeated. You can hear due to the interference. Actually, the reason for these beats is interference of sound waves is causing of beats. Generally, it is used in musical instruments. General use in our laboratory. What is the use of these? General uses are also important. Just in short notes, we can see the uses to determine generally use of beats is to determine unknown frequency. Back you can see to determine the unknown frequency of given tuning fork, and also to detect the presence of dangerous gases in mines. This is industrial use. And finally, in general, we will use musical instrument to give a sound note. Shruti, we call it as. While in musical instrument, we are using the word. So these are general uses of beats. As unknown frequency of a given tuning fork means, which we have discussed earlier, like that in the laboratory we can use to determine the frequency of a tuning fork given. And these are about beats in this chapter. So far in this chapter we have covered all these topics which you have to remember in the point of examination. The beats are very short note question generally he will ask. Next coming some problems which are related these waves we can see now. As far as the syllabus is concerned, we can see some problems. Let me give some simple, these are given in NEET 2018 question. This is the fundamental frequency in an open argon pipe is. You should remember this is whether it is closed pipe or open pipe. You should be very careful while solving that. In open pipe is equal to the third harmonic of closed pipe. That you should remember. The one is open pipe, another is closed pipe. If the length of closed pipe is 20 centimeter, find the length of the open pipe. This type of questions are very, very important. Generally, one question may be given based on this. Here, the fundamental frequency of open argon pipe is third harmonic of closed pipe. Can you see clearly? So, let us solve this problem. First, fundamental frequency of open pipe, that is, you should remember it is open argon pipe is V by 2L, where L is length of open pipe. If it is closed one, what you have to write? V by 4L you have to write. As it is open pipe, V by 2L, and second, third harmonic. Don't confuse to see this third harmonic of closed pipe is 3V by 4L. If it is fifth harmonic means 5V by 4L. All these are open pipes. Open pipes ratio is 1:2, 2:3, 3:4, as we have already discussed in open pipes and closed pipes. As in it is open pipe, the frequencies are in the ratio of natural numbers. So third harmonic means its length should be 3V by 4L. That is length of closed pipe, and open pipe is V by 2L. While you are combining these two, according to the given data, V by 2L is 3V by 4L. L means here length of closed pipe. So 6L, from this we can get 4L, where that L is 4L by 6, 4 into 20 by 6, that is 13.3. Find the length of the open pipe they are asking, and so we can calculate easily that value is 13.33 centimeters. Okay, now coming to the next problem. In the same manner, this is also given in the NEET examination. First overtone frequency of a closed pipe of length L1. First harmonic of closed pipe of length L1 is equal to second harmonic frequency of open pipe of length L2. We have to find L1 by L2, the ratio of closed pipe length to the ratio of open pipe length. These are two different. See the solution. First overtone frequency of closed pipe is third harmonic. As in previous problem and this one, both are similar, but there is a slight change. That is first overtone frequency. The term is changed. First overtone or a third harmonic, both are same. As in case of closed pipe, 1:3:5. That is the ratio we should remember. So first overtone frequency of closed pipe means that is again third harmonic. The problem is the same. As you have considered, this is first overtone is 3V by 4L1, where L1 is the length of closed pipe. Okay. Now, second harmonic frequency of open pipe, no problem to this. If it is open pipe, you can directly use 2V by 2L. According to your formula, if it is open pipe, both sides are open. Therefore, you can usually, you should remember, when it is open, you can use V by 2L, 2V by 2L, 3V by 2L, like that. Easily, right? So, that you can write 2V by 2L2. where L2 is the length of open pipe. So according to the given data, first overtone frequency is equal to the second harmonic. While reading the problems, you should be very careful why I am giving these problems means whether it is first overtone or third harmonic or fifth harmonic, like that, whether he is giving which value. For example, instead of in the previous problem, third harmonic means fifth harmonic is given or fourth harmonic. Fifth generally you will give. Why? Because 1:3:5 is the ratio. Then you have to equate 5V by 4L in the above problem. So here also it is third harmonic 3V by 4L1. While equating this, the 3V by 4L1 is equal to V by L1. From this, finally you can get L1 by L2 as 3 by 4. The MCQ questions he will give immediately. While reading that, immediately you have to write. You practice more. Otherwise, you can't write in the examination. Quickly, you have to understand whether it is closed pipe or open pipe. First, you concentrate the question on open or closed pipe. If it is closed pipe, immediately 1:3:5 you should remember. If it is open pipe, V by 2L, 2V by 2L, 3V by 2L, like that you can remember. So this type of problems you have to do. Now finally, what are the important questions related? I am not giving here all the questions which are related to the chapter. Some important questions I am giving as homework. What are waves and classify the waves? In the very first beginning of the chapter, we have discussed about the waves. What is a wave? Wave is the disturbance produced in the medium, and this disturbance is due to energy and transmission of this energy from one place to another place. That is wave. That is formation of waves. And also classify the waves. How you can classify? The classification of waves also we have already discussed. Electromagnetic waves, mechanical waves, like this, matter wave and gravitational wave. There are 4 types of waves we have discussed, and also given, you can give simple examples also. And second question is distinguish between transverse and longitudinal wave. This is also we have taken a separate class. In the second class we have started this transverse and longitudinal. Whenever there is a differences, it is better to take a tabular form. You take a table, on one side transverse wave, another side longitudinal waves. All the properties, while writing the properties, first one is particles, how they are vibrates. We should write the first point. As the name itself, transverse and longitudinal, along, it means longitudinal waves means along the direction of wave propagation, particles vibrates. That is longitudinal wave. Quite opposite to that, transverse wave means the particles vibrate vertical to the propagation of wave. That is the first difference we have to write. And second, transverse wave, light waves generally consider these transverse wave. Longitudinal waves wave means, example of longitudinal wave, sound waves in air, you can write. So first you write that one, and next example. Like that, there are 4 differences. The transverse waves can show polarization, and here longitudinal waves do not produce polarization. They not show the property of polarization. That also third one. And also we have taken nodes and antinodes in case of transverse wave. And as in case of longitudinal waves, we can see compressions and rarefaction simultaneously forms. So like this, you can write the differences. And third question, explain the formation of stationary waves in an air column enclosed in open pipe. Very carefully you read the questions. Why? Because in the exam, students may confuse some. He is asking open pipes, some are writing closed pipes, or closed pipe is given, they are writing open pipes. That's why both questions you practice carefully and also read the question carefully. This third question is open pipe, and that is a small mistake is shown, and derive the equations for the frequencies of harmonics produced. So what is open pipe? First you have to define. Open pipe means a pipe in which both ends are open. It is called open pipe. Here both open side air particles are free. The air column is present in the pipe. So air particles are free at the open sides. Therefore, antinodes are formed both are open sides. And when a stationary wave or standing waves are formed in open pipe, the first harmonic is formed only one nodal point at the middle. At both sides, two antinodes are formed as shown in the diagram. Like that, you draw the diagrams by writing all these what we have completed. Those diagrams write one by one and explain and find the length in terms of lambda. After that, you can calculate each time new one frequency. V by lambda, where V is here among all these, V is velocity of sound. You should remember V is velocity of sound. In the problems, he may give sometimes calculation of length or lambda also. Then he will give velocity of sound. V is within brackets, he will give velocity is considered 330 meter per second, or sometimes he may given 340 meter per second. According to the problem, the V should be substituted. If he is not giving that value, you take 330 meter per second. Okay, all students carefully understand. I am not giving the problem like that, calculation of that lambda or nu. So I am telling that, be careful. And fourth one, explain the formation of stationary waves in an air column enclosed in closed pipe. Derive the equations for the frequencies of harmonics produced. Here you carefully read, this is closed pipe. Closed pipe means one side is closed, another side is open. It is called open pipe. And here also you draw the diagram explaining all these three closed pipes you have to draw, and finding out the frequencies. New one, fundamental frequency, and second time how they are formed, what is the length of the pipe when first overtone or third harmonic, at a time third harmonic formed in closed pipe. And so we can write 3 lambda by 4, like that we can finally, we can write nu1 is to nu2 as 1 is to 3 is to 5. Finally you write the sentence, the ratio of the harmonics are multiples of fundamental frequency. What are harmonics? Sometimes you may ask that question also. What are harmonics? The multiples of fundamental frequency, minimum frequency, are called harmonics. So the ratio 1 is to 3 is to 5. That ends the problem. Last question, what are beats? And right there, US. Just now we have finished. Beats are formed due to change in frequency when two sound waves are produced at a time. So the number of beats, these beats are formed due to interference of sound waves. Sound waves frequency while interfering, sometimes constructive interference takes place. One wave, where you can see, as according to the principle of waves, principle of superimposition of waves we have discussed earlier. According to that, sometimes constructive and another time destructive interference takes place when two nodal points at a time joining. Then you can see constructive. One node and antinode of another wave is joined, then the displacement is, amplitude is very less. So like this, finally we can heard combining these two waves. When two waves are at a time started and superimposing two waves, we can hear waxing and waning. The waxing and waning, one side big sound and another side low voice. While joining these two, we called it as this phenomena of listening the sound waves. These are beats. And generally, what are their uses? First use we have already discussed it. All the four, there are 3 uses we have discussed: to find out unknown frequency, and also to tune the musical instrument. That is, in general, we will do a musical instrument consists of strings. While you are plucking the string, we can hear one sound. With the same sound, we have to combine with another wave 2 or 3 instruments at a time tuning, then we use these beats. While the frequencies are nearer to it, then only tuning will take place. You should remember. So number of beats are, that also you should remember, number of beat frequency or number of beats per second. That is difference of frequency. That ends this chapter. Thank you, all the students. If you are having any doubts, ask by phone number 8639017573. Good luck. All the best. This ends this time. Thank you.
Madam, good morning, madam. Madam,
Sir.
is it finished?
Yeah, finished.